In this lesson, we're looking at properties of rectangles, rhombi, and squares. So the first activity that they kind of have you or talk you through is creating a rectangle using a tile to kind of build the sides of it. So if you can read through that and follow along with what they're describing, first thing that they're asking you on the next screen that I'll show you is why we are guaranteed that this is a rectangle. Before I get into that, however, I want to touch base on the definition of a rectangle. A rectangle is a quadrilateral with 4 right angles. So if my tile has 4 right angles, then it should just make sense that the resulting quadrilateral that I create will also have 4 right angles. So why does this method produce a rectangle? Because I'm assuming the tile has 4 right angles. You are tracing right angles to create this figure. So it's asking, is every rectangle also a parallelogram? Make a conjecture based upon your measurements and explain your reasoning. Well, I didn't actually draw this rectangle, and maybe neither did you, but looking at a rectangle, for example, this one. Well, I hope that you noticed that both pairs of opposite angles are congruent. And in the last lesson, we proved that if both pairs of opposite angles are congruent, that makes it a parallelogram. Use your measurements to make 2 conjectures about the diagonals of a rectangle. Oops, wrong direction. So, looking at those diagonals, first of all, I hope that you would notice that they are bisecting each other. Remember that in a parallelogram, the diagonals bisect each other. We've kind of already touched upon how a rectangle is a parallelogram. In addition to that, notice how we know this segment is congruent to itself. We know that AD is congruent to BC. And we know that these right angles are congruent. So these overlapping triangles, this one here, and this one here, they're congruent. So therefore, by CPC-TC, and we're eventually going to prove this pretty much in the same manner that I just described, we know that the diagonals are going to be congruent. So my first conjecture is that the diagonals bisect each other. We should already know that with certainty. In addition, diagonals are congruent. So here we're proving it, and as we go through this proof, I hope that you'd notice that I'm saying a lot of the things that I've already said. So we're given that this is a rectangle, and that means that angles A and C are right angles by the definition of the rectangle. And that means angle A is congruent to angle C because all right angles are congruent. Angles B and D are right angles, same thing. they're congruent because of the same reason. And so ABCD is a parallelogram. I called it because both pairs of opposite angles are congruent. So AD is congruent to CB because they're opposite sides of a parallelogram. I know that DC is congruent to itself because of reflexive. Angles D and C are right angles. We already knew that. That means angles D and C are going to be congruent for the same reason. All right angles are congruent. And then, as I said previously when I was kind of talking about the properties of a diagonal, we know, of the diagonals, excuse me, we know that triangle ADC is going to be congruent to triangle BCD because of side angle side. And then remember that anytime you're going further than that, to say that parts of those triangles are congruent, you're using CPC/TC, and you're using it to say that AC is congruent to BD. So we've proven that the diagonals of a rectangle are congruent. The student says that you can also prove that the diagonals are congruent in example 1 by using the side-side-side triangle congruence to show that ADC is congruent to BCD. And as was the case in the last lesson, this is an example of someone using circular reasoning. No, we do not agree. This would be circular reasoning. And remember that circular reasoning is using what you're trying to prove it. So in this example, now we're applying properties of rectangles. We know that AD is 7.5. We know that DC is 10. We're asked to find the length of DB. Well, if AD is 7.5, then so is BC. I'm asked for BD, and what they want you to notice is that that's a right triangle, and they want you to remember that you can use Pythagorean's theorem in order to find BD. So we would do 7.5 squared plus 10 squared equals DB squared. And in my calculator, I add 7.5 squared plus 10 squared. And DB squared equals 156.25. And when I take the square root of both sides, DB is 12.5. In the next example, we're probably doing much of the same. Let's take a look. AB is given to us as 17. BC is 12.75. And they're asking for DB. Once again, I know that the diagonals of a rectangle are congruent, so DB will equal whatever I find to be the value of AC. And if I trace over AC and I trace over the segments that they gave me, there's a right triangle for which I can use Pythagorean's theorem. So DB squared will equal 17 squared plus 12.25, 77, excuse me, 12.75 squared. So in my calculator, I take 17 squared plus 12.75 squared, and that is 451.5625. And when I take the square root of both sides, I get that dB is 21.25. Another kind of special parallelogram is a rhombus. It is a quadrilateral with 4 congruent sides. So notice the diagram on the right, all of those segments are marked congruent. If it's a rhombus, we know that it's also a parallelogram. So everything that's true about a parallelogram is also true about a rhombus. Notice that in that box labeled properties of parallelograms, there's 2 additional properties. The fact that the diagonals are perpendicular, and that the diagonals bisect a pair of opposite angles, each pair of opposite angles. So in this screen, we are proving that the diagonals are perpendicular. So we start off with the fact that since JKLM is a rhombus, JM is congruent to JK. Because it's a parallelogram, we also know that MN is congruent to KN because diagonals bisect each other. By the reflexive property of congruence, we know that segment JN is congruent to itself, so that's why triangles JNM and JNK are congruent by the side-side-side triangle congruence. By CPCTC, I know that angle JNK is congruent to angle JNM. By the linear pair theorem, I also know that they're supplementary. So them being supplementary means that they add up to 180. And since the angles are congruent, their measures are equal. So by substitution, at this point, unfortunately, I have to call your attention to a typo in the text. This should say JNK, because I'm substituting JNK in for JNM in this equation. So once I've done that substitution, I can combine my like terms to get that 2 times the measure of angle JNK is 180. Therefore, the measure of angle JNK is 90, and JL is perpendicular to MK. What can we say about the image of J in the proof after a reflection across MK? Okay, so in this diagram, if I were to draw the line MK and take J and reflect it over that line, its image would be L. And the reason is that that line is a line of symmetry for this rhombus. Wrong direction. So the image of J would be L. what property about the diagonals of a rhombus is the same as a property of all parallelograms? The fact that the diagonals bisect each other. That's the same. What's special about the diagonals of a rhombus is that they're perpendicular and bisect a pair of opposite angles. Actually, they bisect both pairs of opposite angles. And now we're using those properties. So in part A, they're finding the value of xy, or the length of segment xy. The length of segment xy is a side of the rhombus, and since all of the sides of the rhombus are congruent, they used the fact that VW equals WX. So they set those two things equal to each other. They solved for M, and then they took that value of M, the 8, and plugged it in to find the length of VW. So if the length of VW is 36, then the length of XY is also 36. In part B, I'm finding the measure of angle YVW. That's this angle here. So the diagonals of a rhombus are perpendicular. So WZX is a right angle measuring 90 degrees. So if 3n squared minus 0.75 equals that 90 degrees, now let's solve for n. So 3n squared equals 90.75. When I add the 0.75 to both sides, I divide both sides by 3 to get n squared by itself. And 90.75 divided by 3 is 30.25. And when I take the square root of that, n is 5.5. When I substitute the value of n in to find the measure of angle WVZ, here, I have 9 times 5.5 plus 4. So that's 53.5. Since Vx bisects angle YVW, then the measure of angle YVW will equal 2 times the measure of angle WVZ. And they've done the last step for us. When I substitute in 53.5 for the measure of angle WVZ, we find that the measure of angle YVW is 107 degrees. We're using the same rhombus from the last diagram to find each measure. So now we're asked to find the measure of angle VYX. Okay, we already know that YVW is 107. So what angle were they asking me for? VYX. BYX. Oh, well, they're consecutive angles of a parallelogram, so they add up to 180. So 180 minus 107 is 73. Forgot to carry the 1. They're asking me next for angle XYZ, and angle XYZ would just be half of the angle that we just found. So that's half of 73, which is 36.5. Finally, we're looking at properties of a square. A square is a quadrilateral with 4 sides that are congruent and 4 right angles. So why are the following statements true? In part A, if a quadrilateral is a square, then it is a parallelogram. So by definition, square has 4 congruent sides, so that means both pairs of opposite sides are congruent, thereby making it a parallelogram. In part B, if a quadrilateral is a square, then it is a rectangle. So by definition, a square is a quadrilateral with 4 right angles. And by definition, a rectangle is also a quadrilateral with 4 right angles. So a square is a rectangle. The statement is, if a quadrilateral is a square, then it is a rhombus. So by definition, a square has 4 congruent sides. A rhombus is defined as a quadrilateral with 4 congruent sides. So a square is a rhombus. It says, look at part A. Use a different way to explain why this conditional statement is true. If a quadrilateral is a square, then it is a parallelogram. In part A, they use the fact that it has 4 congruent sides. But we could also use that the 4 angles are congruent. So by definition, a square has 4 right angles. All right angles are congruent. So both pairs of opposite angles are congruent. Therefore, a square is a parallelogram.